It's a double triangle question because we're going to have to draw not one, but two triangles. Because there's two angles. There's an angle for alpha and there's an angle for beta. And it tells us that angle alpha is in standard position in quadrant 3. So I can draw something in quadrant 3. If I'm going to make my triangle, it would be back to the nearest x-axis, and the reference angle would be the reference angle for alpha, because the actual angle alpha is this one. But we draw our triangle for alpha, and we know that cos of alpha is -3/5. So we can label on this triangle, since cos is adjacent over hypotenuse, that this side would be 3, this side would be 5. A squared plus b squared equals c squared, and you could solve that that side has to be 4. And then from our triangle here, we already knew that cos of alpha was -3/5, but now we also know that sine of alpha is -4/5. It also tells us that the angle beta is in quadrant 2. So here's my second triangle. In quadrant 2, label the reference angle for beta. And I know that sine of beta, which is opposite over hypotenuse, is 1/3. A squared plus b squared equals c squared would give me this side to be the square root of 8. So I know that sine of beta was 1/3, but now I know that cos of beta -√8/3, because cos is negative in quadrant 2. And the reason we draw these triangles is because if we want to find, I'm going to draw a line here, if we want to find sine alpha plus beta, we know from our formula sheet that it's equal to sine alpha cos beta plus cos alpha sine beta. And our triangles give us those values. Is everybody up to this point? Everybody caught up on copying things down? So it's a double triangle question because we need to draw a triangle for alpha and a triangle for beta. What we knew is, right, the green arrows is what they told us already in the question. They told us already in the question cos alpha was -3/5. They told us in the question that sine beta was 1/3. But by drawing the triangles, we could label the other side, and we could also find out what sine of alpha was and cos of beta. Now that you have these, the next step is plugging things in. And at this next step, whether I teach it to you or not, when you have to do it on your own, about 50% of students make a mistake. If I taught it to you right now the right way, when you got to your quiz, you would make the mistake. So instead of letting you make the mistake on the quiz, because whatever you do right now is exactly what you will do on the quiz for this question or on the test. So I need you to write down the next step. Then off all. First video, completely silent. Wonderful. Great. It's kind of funny. I mean, the good thing is, do you know how to search for the videos really easily on YouTube? Like, I'll teach you that again in case you've forgotten. So you go to YouTube. And you wait, because YouTube takes a long time to load, generally, right? And then Okay, and then our class, 40 SP. We are currently in chapter 7, in section 5. Chapter 7, section 5. And we just did example 3 without sound. So if someone wanted to search example 3, push enter, 7.5, example 3. I have one from 5 years ago, from 5.7, don't watch that one. Here's 7.5, example 3 from 4 years ago. Here it is from 6 years ago. You can, every year I make new videos, but if there is a chance that the volume is off, right, then you have access to older ones if you want them, right?
How long have you been recording videos for?
I started before the pandemic. I don't know what my oldest video.
I looked at it, it said like you got 2.9,000 videos.
I have a lot of videos, right? That's a lot of time to put on the videos. Yes, so there's a bunch of them there. The only difference in the 6 years ago one, maybe, talking different, right? So if I'm, make fun of a different student, like I said, Jeremy looks funny today, then you wouldn't know which student I'm making fun of. I turned it on mute so that I can't get in trouble for making fun of Jeremy by saying he looks funny. Okay. Whew. Anyways, so you can find examples even if we have a technical glitch like what just happened, that the sound was off. And now there's going to be this little aside in this video about finding videos. But what I was saying is I'm going to now take statistics. You are all going to write the next step down. And we're going to find out, and it's amazing, every year it's like 50%. Even if I tell you, some of you are going to make a mistake, you're like, trying extra hard. Some of you still make the mistake. So it's better if you find out now that you're one of those ones that are making that mistake and learn from it now instead of learning from it on your test when it counts for marks. Okay, so I will pause the video, you write down. Look back. Results in this class. 10 out of 17, which is as a percentage.
Like 10 got it right.
59%.
No.
Got it wrong. 40% or 41% got it right. The common mistake, which even if I show you the right way to do it, you would have made the same mistake on the test, is where you plug in the -4/5. What is the -4/5 equal to? Is it equal to just the alpha or the whole thing? It's equal to the whole thing. So you replace all of this with -4/5, all of cos beta with -√8 over 3 plus all of cos alpha with -3 over 5 and all of sine beta with 1/3. But what your brain just did is you are so used to plugging in values for variables that your brain just said, I'm just going to replace the variable with -4/5. But you don't know what alpha is, right? Nowhere did we figure out what alpha is. We just know sine of alpha, cos of alpha, sine of beta, and cos of beta. You don't know alpha. And you can't find alpha unless you had a calculator. And this is a non-calculator question. If you do it the right way, like this, now the math can be done, because there's just numbers left. We have to write our answer as a fraction in the end. Can you see you can multiply those two and you get 4√8 over 15. And if I multiply these, I would get plus a -3 over 15. And I could have simplified that, but it's nice to have the common denominator because you have to write your final answer as a single fraction. And you can leave it like this even though the √8 could get changed to 2√2 and you could write it further simplified, but you don't have to simplify square roots in grade 12. Because they assume you know how to do that, right? 4 root 8 is the same as 8 root 2. You know how to do that, so you're good. Yeah.
Yeah.
Yeah, super strong in that sense. Excellent. Okay? So, most of you made that mistake, and that's a normal mistake to make. And even if I showed you this, like, it used to be when I started teaching, I just started teaching. And I taught it the right way. It's not like I decided, oh, this year I'm going to teach the wrong way, see if they do it right on the quiz. No, I taught it the right way, but still so many people made the mistake on the quiz in that substitution. So I rechanged how I taught. I like, hey, if you're going to make that mistake, make it now. And some of you will make it again on the quiz and the test. That's going to still happen. Some people decide, even though you showed me I made that mistake, I'm going to make it again. Try not to, but I find that it's much less. And then hopefully by the final exam, you're really careful in how you do your substitutions, that you're not making that mistake anymore. Okay. Circle the following questions. 8 and 13. Most students actually love the double triangle question because it is very predictable. Yes.
For the left side, like the sign A plus B, do you leave it as that? Or do you also?
Yeah, like all the way down, this is what sine alpha plus beta equals, and that's what they want us to find. So that is equals all the way down as our answer. Excellent.